Please remember, I've given you a handy-dandy shortcut that works when you start with a single letter. If you don't remember the shortcut, you got to actually multiply it out. X squared plus 7x minus 5x minus 35. X squared plus 2x minus 35. This one. 6x cubed plus 9x squared minus 10x minus 15. I didn't stack them because there's no like terms. Is done. You cannot add these two together because they are different. This one, 28x squared minus 7xy plus 8xy minus 2y squared. I lined up the x and y's because they're like terms. And I get an answer of 28x squared plus 1xy. Do we write 1? No. Xy minus 2y squared. This one, is it 9x squared plus 4? No, because it's 3x plus 2 squared, which means I have to multiply the whole thing to get 9x squared plus 6x plus 6x plus 4 to get 9x squared plus 12x plus 4. Yeah. This one, barfy. 2x minus 5. 2x minus 5. 2x minus 5. Now, I like to take care of these two first, so I'm going to leave 2x minus 5, and I'm going to take care of this one. 4x squared minus 10x minus 10x plus 25 to get 2x minus 5 times 4x squared minus 20x plus 25. Then I got to do it all again. 8x cubed minus 40x squared plus 50 minus 20x squared plus 100x minus 125. To get a final answer, I'm going to write it over here, 8x cubed minus 60x squared plus 150x minus 125. Now, some of you aren't going to have gotten that, as I've just been informed. What is your responsibility now if you didn't get that for a final answer? Figure out why. I have every single step there. I need you to recognize and diagnose where your error occurred. If you cannot find it, then you should be looking through your work and seeing what you did differently than I. The most often, or usually the biggest error is you forget how to do the signs. Like you forget that's negative and that's negative, so it makes a positive. That is often a problem. And that's not knowing how to do math. That's just an error, right? That's not, I don't know what to do. That's, I will give you a moment to look over that before I go ahead. Remember, you're new at this. Drawing the arrows might actually help you. Don't feel bad doing that. Some of you may even wish to use the tiles to do this. That's okay. Don't feel bad. Are we ready to go onward? All right. Remember, don't be discouraged by the size of the question. Just think to yourself, what would I do if there was no y there? Well, I'd put that x through everything. And I would get 2x cubed, because x times x squared, minus 4x squared y, because the x's give me x squared and there's no other y, plus 3xy squared. Then I'm finished with the x's. Then I would say to myself, self, now I'm going to run through with the y. 2x squared y. Oh, I have some x squared y's right there. 2x squared y. Minus 4xy squared. Oh, I've got some xy squareds. Plus 3y cubed. Then I just collect it. 2x cubed minus 2x squared y minus xy squared plus 3y cubed. Yeah? Yeah. And these two at the bottom always scare kids because they look crazy complicated, but it's not. If none of this were here, you would multiply that. You would get 8, what? X cubed y cubed. Then you're going to add this one, minus 4x squared y cubed, because there's no letters with that one. Then you're going to do this one, plus 2. What do you do with the 2 and the negative 1? It's just x, because it's 2 minus 1. And 3 minus 3? Nothing. It's y to the 0. Y to the 0 is 1. We don't write 1. Anything to collect there? No, because there's no like terms, so it's done. If you put y to the power of 0, I would not take any marks away from you, but I cannot guarantee your future teachers wouldn't, because you don't write y to the 0, because y to the 0 equals 1. Now, something that has helped my students in the past when they're looking at this is this, coloring each term. Then you know you've got to do 3 of them. Why is it no matter where you sit, no work gets done by you and the people around you? Okay. So that means you have n done, right? Interesting. So, take this, multiply it by the yellow one. What happens with the 4 and the 3? He waited for his 10th graders to tell him what 4 times 3 was. 12. Yay. What do I do with x cubed and x to the 4th? X to the 7th. And y to the 8th. Now I move on to this term. What do I do with the 4 and the 7? To get? Minus 28. X cubed and x cubed? X to the 6th. Y to the 6th, then nothing. Stays y to the 6th. Plus 4 times 8. 32. X to the 3. And y to the 8th. Now, is this in proper order? Again, I don't care, but is it? Yeah, because we start with the x's. 7 6, 3. It's in the right order. Okay? Everybody understand? But again, I don't care about that order. Is everybody good? Can everybody multiply? Nathan. You didn't have to split it up because you only had one thing that was being multiplied. You had a monomial multiplying in here. Okay. Everyone is good? All right. Now we are going to learn to reverse what we have just done. Because when you reverse what we have just done, you can make very large equations much, much simpler. Okay? Turn the page over. I'm going to start nice and easy. This process is called factoring polynomials. Now, we've already used factors this year, yes? We already know how to factor something. We had 36, and we broke it down. 9, 4, 3, 3, 2, 2. Right? That was one type of factoring we did. There is also another type of factoring that we do. We take 36 and we break it down into factor pairs. 1 times 36 is 36. 2 times 18 is 36. 3 times 12 is 36. 4 times 9 is 36. And 6 times 6 is 36. This is another type of factoring. Also something you probably did at some point in your earlier math career. Everybody has seen both of these, yes? So when I say factor a number, you know you're either making the factor tree or you're breaking it down into these pairs, right? Okay, well now we're not going to be factoring single monomials. We are going to factor polynomials. So as this is written here, what would you say if I asked you to read that to me out loud? What would your words be? 4 times x minus 5. It's hard to say x minus 5 with brackets, right? But when you say x minus 5, I know that you mean they're together. Everybody cool? So if this number 4 is multiplying by x minus 5, and x minus 5 is in brackets, doesn't that make this 4 a factor? And doesn't that make this x minus 5 a factor? So, of course, here we have 2 factors, right? All right. Now, if we were to multiply this out, we would get 4 times x, right? Minus 4 times 5, which would get us 4x minus 20, right? This is the product. Now, you can quite plainly see that no matter how we do this, if we drew it or if we did it with algebra, you can quite plainly see that what we have done going this way is called expansion. And it involves multiplying. I'm going to run out of space there. Multiplying. So if I reverse that direction, I have what is called factoring. Now you people are intelligent people. If I reverse multiplying, what am I doing? Dividing. Everybody cool? All right, now take what I have written here and apply it to here. How would you write the notes to this for me if I didn't know what I was doing? Does everybody understand what I'm saying? What is this written out this way? Where are the factors? Where are the products? What is the product? Okay, go. Okay. What is the first factor? No. X plus 4 is the first factor. What is the second factor? X plus 2. If I want to make the product, what do I do? I do x times x plus 2 times x plus 4 times x plus 4 times 2. And what do I get? X squared plus 6x plus 8. This is the product. Now, you can see, and I would stand up, but my leg is killing me. You can see that we started with a binomial and another binomial, and then we expanded to get a single trinomial. Everybody cool? Okay. Now, here I've written factor 12. In this unit, when we are looking to factor something, this is the factoring we do. So take this and apply it to 12. What are the pairs you would write? 1 and 12. That's the easiest one. What's next? 2 and 6, and then 3 and 4, and then we're done. Right? Because once they're very close together, you can't go any further. Right? Everybody good? Okay. We are not going to actually get at algebra tiles because it's been years since I've had a complete set. We are going to do this with a picture. This is a product because I am asking you to factor it. Just like I factored 12, I broke it down into pairs, yes? So we want to break this down. Malik, can you please just go sit over there behind Kezia and stay there and do some damn work? We're going to break this down into pairs. Now you can see that this is a binomial, yes? Now, you're intelligent young people. 2 binomials got me a trinomial. When I broke down a trinomial, I had to have at least a binomial, yes? So when I break down a binomial, what am I going to have at least one of? A monomial, right? Okay, so I'm going to have to break this down. I have 2 parts to this, don't I? I have 6x and I have 3. How could I break down 6x? What are my options if I was asked to factor 6? It could be 1 and 6 or 2 and 3. Agreed? What is the ways I could break down 3? 1 and 3. It's the only way I can do it, yes? Now, what do you notice about all the pairs? There's always 1. So is 1 going to be very helpful to us? No. All right. What else is there that you notice? There's a 3 in both of them, which means 6x can break down into groups of 3, and 3 can break down into groups of 3, correct? Now, if I want you to draw this for me, you know that I need a rectangle, right? And you know that I can't use 1 and 6 because 1 is useless. So I got to get 2 and 3 of x's, and the x's are bars, and 3 and 1 of these little guys to fit into a rectangle. How can I do that? What are my options? I could put, I need a rectangle in here. So what are my options here? How will I draw 6 of these and have them make a rectangle? Can I do... I know I can't do 6 and 1, can I? Okay. So I have a choice of this or this, correct? Are both of those right for 6x? Yeah. Now I got to get into the rectangle. I got to get 3 of these little guys. What are my only options for 3 of the little guys? I could go 1, 2, 3, correct? Or I could go 1, 2, 3, correct? Which one makes a rectangle, the top or the bottom? The top. So this is my product. 1, 2, 3, 4, 5, 6 x's, right there. 1, 2, 3, 3, right there, correct? What are the factors? Where do the factors live? On the outside. How far is, what's that and that? 2x, and what's that? Plus 1. What's that? 1. What's that? 1. What's that? To make 3. Now we check. We guess that our factors are 3 and 2x plus 1. Is 3 times 2x indeed 6x? Yes. Is 3 times 1 indeed 3? So the factors of this are these. Is everybody cool? Okay, I'm going to make it one harder when you turn the page over. Is it still a binomial? Yep. So I know my factors are going to have to be a monomial binomial, yes? Okay. So that means I got to break down 4x squared and 6x. What are my options for 4x squared? 1 and 4 or 2 and 2, correct? So I am either 1, 2, 3, 4, or 1, 2, I'll move this over. 1, 2, 3, 4. Agreed? Okay. What are my options to break down 6x? I'm either 1 and 6 or 2 and 3, correct? 2 works here, but not here. 6 doesn't work anywhere. 1 works everywhere, and 3 doesn't work anywhere. But you notice that 2 works in both. So, 2 by 3. So, 1, 2, 3, 4, 5, 6. Do I have my rectangle? What's this? 1x. What's this? 2 x's. 1, 2, 3. So this is 2x plus 3. What's this? X. What's this? X. 2x. So what are my factors? 2x and 2x plus 3. And I can easily check 2x times 2x is 4x squared. 2x times 3 is plus 6x. I've made a rectangle and I'm good to go. Is everybody good? Those two are what we need to continue on today. We're not going to deal with this guy until you're writing a test tomorrow. Wednesday we'll be dealing with this guy. Okay? So we're going to skip over that and move on to page 127. Yes, please take a washroom break right now. No, I told you guys that's been a minute. So, please notice I've entitled this number 1, greatest common factor. That means it's the first type of factoring I'm teaching you, which means it should also be, if it's the first one you're learning about, it should be the first thing you try. All right? Always, always, always. When? Always. Oh, certainly you cannot possibly mean always. Yes, always. Every time you are faced with any math problem, if you can do the greatest common factor, you always do this if you can. Okay? And it's very, very easy to do. Now, the last thing you did for me was 4x squared plus 6x, yes? And you broke it down into 1 and 4 and 2 and 2, and you broke 6 down into 1 and 6 and 2 and 3. Agreed? And then Satjot said the key word, common. He knew we had to use the groups of 2 because 2 was the greatest common factor between both of them, right? And when we actually did the work, we ended up with 2x times 2x plus 3, correct? Right? Now, 2 is certainly the greatest common numerical factor, but what does this really mean? No, just the x's. It means x times x, right? And what does this really mean? A single x. Please notice that 1x is also common to both of them, right? So then, the GCF of 4x squared and 6x equals 2x because of the 2's and the x's. Does everybody see that? That is the first step in this kind of factoring. Step 1 is decide on the GCF, which we have just done. Everybody cool? Now, since we are factoring, what math must we be doing? Dividing, because we're reversing the multiplying, yes? So, we have decided on a GCF. Have we done any division yet? No. That is step 2. Step 2, you divide all terms by the GCF. So, my original terms were 4x squared plus 6x, correct? So now, I've done step 1. I decided on my GCF was 2x. Step 2, I divide all the terms by the GCF. So I divide that by my GCF, 2x. Divide that by 2x. And then step 3 is write the answer in the following form. GCF bracket. Then you put your, I'm going to use the proper math term for it because it's math class, the quotient. Quotient is the answer when you do division. So quotient 1 plus or minus quotient 2 plus or minus quotient n. You keep going until you're out of quotients. Okay? So, step 3 here, which I will do in green, what was our GCF in this question? 2x. So I write GCF first, then a bracket. What is this answer? What is the answer to 4x squared divided by 2x? 2x. 4 divided by 2 is 2. X squared divided by x is x. Quotient 1, done. Plus or minus, which one is it going to be here? Plus, what is 6 divided by 2? 3, and x over x cancels out, and I am done. Does everybody see how to do it? It's pretty easy, right? Let's start with the easiest one we can. Step 1, in black, what is my GCF? 5. Step 2 in blue, divide all the terms by 5. Step 3 in green, write out the answers. GCF first. My GCF was 5. No, we're doing this one. My first answer was X plus my second answer, 1. Done. What's my GCF here? GCF equals 3. Step 2, divide by the GCF. Step 3, write it out. 3. What is the first answer? 2x plus, what is the second answer? 1. Number 3. What's my GCF? 3. Decide on it. Divide by it. Write it out. 3. What's the first answer? X squared plus 4x minus 2. Done. And lastly, the one we worked on for an answer, or for practice, GCF equal 2x. Divide by 2x, divide by 2x, write it out. 2x, 2x plus 3. So easy, yes? All you're doing is dividing like grade 2 and possibly dividing exponents like grade 10. Is there anything today that is new math? No. Go. Do those 4. Yes, that's how everything you ever learned in your life is. The first words you learn, Mom, Dad. And now, well, Father, I'd like to borrow the automobile tonight to go out on a dinner accompaniment with a young lady whom I have just met from school. But your first word was, Dad, which wasn't even a word, but your parents were like, oh my God, he said Dad. But you didn't. You were just farting. Right? But parents are funny that way. He said his first word. What did he say? What? Can't you hear? That was Mom. So, what was my GCF? 5x. Because there's an x in all of them. Step 2, divide them all by my GCF. Step 3, write it out. GCF first, then all your answers. How many answers do I need here? 3. What is the first one? 5y. Plus, what is the second one? 3x. What is the third one? Negative 6 xy squared. Okay. What is the GCF here? 2. Divide by 2, divide by 2, divide by 2. Rewrite. 2, bracket. 4 plus 5a plus 3a squared. Yeah? Yeah. Third, GCF equals 5 CD. Why only one C and one D? I can see there's 4 C's there. Because the last guy only has 1 to give. Why only 1 D? Same thing. What's the first one? Negative 4 C cubed minus minus 5. Now, even the back corner gentlemen need to shut up and pay attention now. Because all of you are going to say that is done, and you are technically correct, because 5 is the greatest common factor there. But, put a little asterisk. We hate this. We hate a negative at the beginning of a bracket. So what we like to do is we like to bring out that negative as well. Okay? So this would really become negative 5CD, and what would this be? 4C cubed, and what would this be? Plus 6C squared D, and what would this be? Plus 5. We like this. We want the negatives moved as far to the left as we can. But only if there's a negative at the left in the first place. Do you all understand what I mean? Okay, that's why I wanted everyone to pay attention, because this is what we want to do. Everybody cool? All right. Can this one even be done? Why not? Nothing's common, so it's done, because we don't use 1, because 1 is common to everything. Are you all good? Great. Page 128 is your homework. Nine questions.